Mike, are you okay? Please turn off your cell phones. I asked Mike Allison to actually give a talk on some planetary research. Mike's involved with the Juno mission to some degree, given that we just had this very nice talk from Tony about the Cassini mission. But Mike insisted that he thought it would be more appropriate to talk about the history of this place up to around 1991 or so, and that's what Mike's going to talk about today. So.
Thanks, Mike. Well, as Mike says, I was going to talk about Juno, but we've had an excellent talk by Tony. You don't need another talk on that subject. And then I was very affected by Jim's retirement, as I'm sure you were. It kind of set my mind reeling as to wondering more about where this place came from and what I was doing here, what we were all doing here. And so I dug into some research about the early days of the Institute in my own personal context as someone who grew up with the space age. So I've gotten help from several people, by the way, I want to acknowledge, who must, however, be felt blameless with the content of this talk. Vittorio sent his regrets. He's in Rome today visiting with the new Pope. Rome pizza lunch, I don't know.
Trying to get the Pope to
I feel I should make some disclaimers. I'm going to try to talk about the history of an institution that began when I was about 8 years old. So obviously, this is not all personal reminiscence. A lot of it is my attempt to dig up some historical documents. And it's also strongly tinged by my point of view as a space scientist. This story could be picked up by someone else from a different point of view, but your guide today is an old space cadet. These are some of my sources, just a few of the sources. I couldn't list them all on one slide. But this was the start of what has been called the space age, the launch of Sputnik, October 4, 1957. It shocked the world. It's hard to characterize this for someone born since that time. Some people have compared it to 9/11, although no one was killed by Sputnik. We came to the very precipice of a catastrophic decimation of human population with the Cuban Missile Crisis, which was a part of the unfolding of the warming hostility between America and Russia. If you want to try to catch a sense of the emotional freight of those times, I'd suggest a look at the movie October Sky. But it much affected me. I grew up as a part of the Sputnik generation. This is me at that time. I actually witnessed the overflight of Sputnik from my front yard in Salem, Illinois, when I was about 6 years old. These are some of the books from my library. All of a sudden, everyone was talking about space. It was on television. It was in advertising. Schools were suddenly stimulated to develop new programs and new math. I know for a fact that Tony also read that book as a kid because he spotted it once in my apartment.
Yeah.
That was
me. We recognize it.
So that's what we grew up with. This was during the term of President Eisenhower, who was really in the hot seat. He had to do something. President Eisenhower, it seems to me, was possessed of a few clear ideas, even if he wasn't Republican. Among them, the insistence that NASA be formed as a civilian space agency, unlike the Russian program. He, of course, was the general of the armies in World War II. For a time, he was president over at Columbia. But in 1958, he signed the National Aeronautics and Space Act, passed by Congress. And this is a photo of him swearing in the first NASA administrator, Keith Glennon on the right and Hugh Dryden on the left. Well, a couple weeks earlier, in Moscow, a nuclear physicist named Robert Jastrow had stood up at a Russian IGY meeting, International Geophysical Year meeting, to counter the claim that the Sputnik rocket that launched the satellite had fallen somewhere in the western United States. And Premier Khrushchev personally asked for the return of this rocket. But Jastrow, working with a colleague at the Naval Research Lab, did some calculations which he claimed convincingly showed that no, the rocket stayed up for at least 8 hours past its flight over California. I've often wondered how Jastrow got into this kind of work. He was a nuclear physicist. He did postdoctoral work at the Princeton Institute for Advanced Study. He was famous for the devising of a simple analytic representation of the nuclear potential that came to be known as the Jastrow potential. And I conjecture that that work primed him for the later study of the interaction of exospheric electrons with the charged hard sphere of a satellite. And he wrote a lengthy paper about that, but it turned out that really the practical determination of the satellite orbit was more nearly a matter of classical dynamics and numerical computation. I've tried to recreate in a simple, approximate way this calculation. This plot on the left is my idealization of the vertical density profile of the Earth up to 400 kilometers. It was not known all that well back then. It was first founded by rockets and the observation of meteor trails. But Sputnik was tracked repeatedly by radar stations around the world, and they observed towards the end of its life a rapid decline in its altitude at Stanford and in England. And Jastrow calculated that it must have stayed up for 6 or 8 hours beyond its last pass of California. And of course, as the Earth rotates with each 90-minute orbit, that took it far off the track of the continental United States. I've found that I can approximate that calculation assuming just aerodynamic drag, a v-squared force drag proportional to the density, and to the extent that you can represent the scale height as a constant in the lowest 80 miles, I can kind of convince myself that Jastrow and Harris did the math. Well, he acquired an enormous, he gained a lot of political capital from this achievement, and he received a lot of notice. He was recognized as a superb speaker. One of his superiors, as quoted in the New York Times, said that he combined an aggressiveness with intellectual brilliance, and he was able to draw a wide variety of people to him as a result of that. He had said that this was his first acquaintance with atmospheric physics, but in just a few years, Jastrow was the editor or co-editor of the Journal of the Atmospheric Sciences and held that post for about 10 years. He was, by many accounts, quite a character. He was athletic. He would often pull colleagues out of the office to go running around the Central Park Reservoir. I remember Tony used to say that he'd call up his office mate, "Scott, do you want to go play handball?" And he was always dragging people out to do something like that with him. One of the first GISS staff members, Rasool, said that his favorite gadget was a telephone, and he could pick up the phone and use his name and use NASA's name and get all kinds of things to happen. Well, Jastrow joined the agency toward the end of 1958. One day, Homer Newell, a NASA administrator who wrote this book, Beyond the Atmosphere. It's a source of a lot of my material for the early formation of NASA and space science. He wrote this book, and which I'm going to return to the library if you want to have a look at it. But one day he asked Jastrow to lunch and said, well, he liked his work on the Sputnik, and would he like to come in with him from the Naval Research Lab and join this new NASA organization? So Jastrow said, well, sure, that sounds like fun. And within a month, these guys were really feeling their oats. They were just itching to do something. They had the open purse of the country to get a space program going. And Jastrow wrote to the NASA administrator, Keith Glennon, and said, we ought to have this fellowship program to pull in university postdocs and professors, and it ought to have a good, healthy stipend, and you can maybe administer it through the National Research Council so it's not tainted with bureaucracy. And Glennon said, good, let's do that. And he signed off on this memo on Christmas Eve in 1958, And this enormously successful program was launched that enabled many of us to get our start here, and many other scientists their start elsewhere in other NASA centers. It soon spread to JPL and eventually beyond NASA to the U.S. Geological Survey and the EPA and NOAA. I've listed here just a few of Dr. Jastrow's designated advisees at the Goddard Institute. This is only a small sample of a total of 85 that he was assigned to advise, and he may have farmed out that advising, but at least he was able to establish all these new salary lines for young scientists. About the same month, December 1958, Jastrow decided to fly out to California and talk with Harold Urey, the renowned planetary scientist. And Urey said, well, we ought to, this new agency ought to do something about the moon. The moon has no atmosphere, and so it may be a Rosetta Stone for the formation of the Earth and the solar system. So they flew back to Washington and talked to Homer Newell, who wrote this book, and said, we should have a lunar exploration program. Good, let's do that. And they wrote up a memo, and it was approved. And in a few months, Robert Jastrow was the head of the first NASA working group on lunar exploration, and that was the start of the Ranger mission. When I first came to GISS, there was a great big, roughly 5x5 photo image of the moon from the Ranger collision onto the Alphonsus crater, hanging out there somewhere near Rob Schmunk's office. And I always wondered about that. Now I know that was a part of Jastrow's acquisition in his affiliation with the Lunar Exploration Program. We haven't done a lot of work with the moon, I guess, in recent years. I think Michael Mashenko did something with the Clementine colorimetry. But in the early years, there were several conferences, and in fact, just a few weeks before Apollo 11 landed, there was a major conference here on the moon with a review of what was then known about that, including Hal Mazursky and Norm Ness and Harold Urey, and there was a report written about it that's still bound in our library, written with the help of Vivian Gorditz. Well, okay, so he starts the Ranger program, he starts the NRC program, then Jastrow got the idea that maybe we should start a new theoretical institute. And in October of 1960, he wrote another memo to his boss, Abe Silverstein, who was the director of spaceflight programs at NASA headquarters, with the proposal that a new institute be created. And this emerged as an offshoot of the theoretical division to which Jastrow was originally assigned, which was going to be a part of the new Goddard Space Flight Center, but that center did not yet exist. And so in the early months of NASA, Jastrow was able to propose this up through headquarters management in a very fast way. And in just a few months, again, the administrator said, good, let's do that. And he signed the memo, and the creation of the Goddard Institute for Space Studies was approved in January of 1961. So 2 months after the headquarters approval of this new institute, and 2 months before it moved to New York from a Maryland furniture store where it was temporarily housed, NASA at the same time dedicated its new major center in Greenbelt. They were going to call this the Beltsville Space Flight Center, but someone decided we should think of a better name than that. And so they decided to name it after Robert Goddard, the rocket pioneer. And the dedication occurred on the 35th anniversary of the first of the launches of the world's first liquid fuel rocket. And this is Robert Goddard's widow unveiling a bust commemorating her husband with Abe Silverstein. I thought I might just mention that GISS emerged in a way as a compacted acronym of the Goddard Space Flight Center Institute for Space Studies. If you look up the early publications, they typically read Institute for Space Studies or Goddard Space Flight Center Institute for Space Studies. Later, it was often referred to as just Goddard Institute. People here started talking about the Space Flight Center as Goddard, and people at Goddard objected to that, saying, well, we're a part of Goddard here. So I thought I would just briefly pay some homage to the center's patron saint, Robert Goddard. He had, as a child, an epiphany sitting in a cherry tree on an ant's farm in Massachusetts, in which he suddenly imagined the possibility of flying to Mars. And in that moment, he dedicated his life to studying physics and mathematics so he could make this happen. And although he was a kind of mediocre student and very sickly, almost died of tuberculosis, he suddenly mastered physics and became a professor at Clark College and began to do experiments with liquid rockets. He had at first the support of the Smithsonian Institution and wrote a paper called A Method of Reaching Extreme Altitudes, but he was lambasted in the New York Times as a nut, claiming that he doesn't know the need for something better than a vacuum to react against. This will never work, and of course he only seems to lack the knowledge ladled out daily in high schools. And when Jim was lambasted by Joe Nocera, I sent him an email with some quotes from this, and I don't know if he did that extra bit of mail in his inbox. But it's interesting to know that even the New York Times can be wrong. I'm also glad to report that although our library has necessarily de-accessed a lot of the astronautics books, we retain several on Robert Goddard. Well, back to the Institute. As announced in May 1961, the Institute moved to New York, finding its first home in the Interchurch Center over on Riverside, and took up most of the fourth floor there for its offices, and brought with it an IBM 7090 computer installed on the top 19th floor. And Rasool recounts this in his memoirs, which is also the source of a lot of my anecdotal material. Ichtiaque Rasool, My Life from Riches to Rags and Almost Back Again. He was one of the original staff members. I'll have more to say about him later. 2 weeks after, or in the same month as the move to New York, Kennedy made this famous speech in which he said first he believed that this nation should commit itself to the goal before the decade is out of landing a man on the moon and returning him safely to the Earth. There were some other very interesting provisions in that speech, largely forgotten today. An extra $23 million for the development of a nuclear rocket, which Kennedy said held the promise of voyages to the very end of the solar system. $50 million for a network of communication satellites, and fourth, $75 million for an Earth-observing platform in space, $53 million of which would go to the Weather Bureau. Well, people continue to debate, really, whether Kennedy's interest in all this was genuine or whether it was mostly a ploy to oppose the Russians in the Cold War. But ploy or not, it was a tremendous stimulus to NASA funding and research. Ichtiaque Rasool recounts that because of this speech, there was suddenly plenty of money at NASA and here at the Institute, and Columbia had the brain power. All they had to do was go to work. Jule Charney, who was a visitor here, recounts that he was drawn in by a presidential commission under Kennedy to studying the possibility of a global observing system. I don't know what Dr. Jastrow may have thought about Kennedy, but I have found his sign out on this library card from our library of the first volume of Kennedy's speeches, so he must have had some interest in it. This is a photo of the then JPL director, William Pickering, presenting a model of the Mariner spacecraft to Kennedy. That spacecraft and variations were used to study Venus and Mars. Kennedy's last speech delivered before he was assassinated was, of course, in Texas in which he said, "This nation has tossed its cap over the wall of space, and we have no choice but to follow." So those were heady days. The Institute goes to work. This is, as far as I can determine, a more or less complete list of the original GISS staff, including Al Arking, who went on to Goddard to continue his work on the Earth energy balance, Norman Baker, Columbia Astronomy. I'll say more about Cameron and Rasool and Pat Thaddeus. One source states that the Institute's primary mission was to provide the theoretical support to analyze, interpret spacecraft data. That's a very interesting idea to me. Today, each flight project thinks it has its own team with more than sufficient expertise to work the data for their mission. But back then, as NASA scrambled, the idea was that maybe GISS could do some of that work for the new flight missions. But the second major objective was to pull in people from Columbia and Princeton and New York University and others on the eastern seaboard to help with the NASA mission. This is the first organizational chart for Goddard. This is the Institute for Space Studies, headed by Robert Jastrow, reporting to himself as the head of the theoretical division under space science and satellite applications. In a short time, the Institute was detached and from the theoretical division, which had a new director, and GISS was placed directly under space science and satellite applications. And then later, Jastrow managed to bring that box up further and attach it directly off the director's office, what was then called Code 130. The announced first major activity of the Institute was a conference on the origins of the solar system. There's some famous people here, a couple of guys here with an attitude sitting in the front row, Jeffrey Burbidge and Fred Hoyle. Margaret Burbidge, also a renowned astronomer at that time. My first experience, or my first knowledge of GISS and the work here was through this book that I was assigned to read in college in a class that I took on religion and science, Red Giants and White Dwarfs. And in reading this book, I first became aware of the modern deduction that our world, all its carbon and oxygen, everything of which we are made, and the world that surrounds us was entirely manufactured inside the nucleosynthetic burning of stars. And that just took the top of my head off, and who needs religion? I was ready to switch to physics, which I did. I just thought that was incredible. And in the early years, there were several conferences here and a lot of work done here on nuclear astrophysics. This is a photo from that book, Red Giants and White Dwarfs. Robert Jastrow, Ed Spiegel from Columbia, Al Cameron, other famous people, Don Clayton. This, I think, is an incredible picture. The three of the most outrageous and contentious and infuriating and endearing physicists of the late 20th century, Fred Hoyle, Tom Gold, and Freeman Dyson. I used to think that they were standing here in this room, but if this date is correct, they must have been over at the Interchurch Center on Riverside. I don't know. Well, this is the first of several personalities that I would like to, just a handful of personalities I have selected to feature in this presentation. Alistar Camron was here between 1961 and 1973. He occupied what is now Barbara Carlson's office. He was a polymath. He worked in nuclear astrophysics, solar system formation, lunar origins, magnetospheres, neutron star physics, turbulence theory, atmospheric evolution, cosmic abundances. He wrote 55 papers and co-edited 7 conference proceedings in 7 years. He loved to play with computers. At first the mainframe at GISS, but later he liked to have his own computer clacking away in office. Someone noted that given his interest in the creation of the solar system, some people thought it was amusing that his institute's home was housed in the Interchurch building. He notes in his autobiographical notes that in the early years, this institute spent a lot of effort on the organization of conferences, and that this was a great project for graduate students. They have these meetings, and the discussion would be tape recorded, and then the graduate students would be hired to translate that into a written transcript, and it would be sent to the authors, and they'd make a book out of it. And having done one of these myself, I know that's a very labor-intensive effort, but I think it's a very nice thing. I think that these books present with their transcript of discussion a more realistic account of how science is done than when you read a paper and get the feeling that it just kind of ineluctably flows from the funding source. When you read these books, you get the feeling of contention and aggravation and uncertainty and confusion. And I especially like the book that Jim edited on the atmosphere of Venus. I don't know if there are any more copies of that book around, but there's certainly one or two in the library.
I've got it.
But I've got a stack of the Jupiter conference that I organized, and you're welcome to take one. And if these are gone, I've got a few more that I might put up in the library and finally get rid of these. Well, this is the oldest photo that I have of this building in the time that it was occupied by the Goddard Institute. This photo was by Patrice Palmer back in the 80s. Rasool claims that the move to this building from Riverside occurred in 1963 before Kennedy's assassination, but I have other sources that place that date at a later time, and I'm not quite sure when it happened, but it certainly happened by 1967. And this is the oldest photo that I could find, in fact posted on the website for Tom's Restaurant, not precisely dated, but around 1935, and touched up here in this nice colorized postcard. Rob Schmunk has done some work on the history of the construction and lease of this building, which was originally the Austin Apartments and later the Oxford Hotel. Columbia acquired the building sometime around 1965 and named it Armstrong Hall after a Columbia graduate who was an inventor in electronics. And as you can read on the plaque outside the main door, for a brief time the philosopher John Dewey lived here. But Rob can tell you a lot more about this building. This is a... Yes?
Are you saying that GISS moved here before Columbia bought it?
I don't know. Rob says that Columbia was kind of doing some tricky things with the deeds and the ownership and making it look like one thing when it was really another, and I don't know.
I'm pretty sure it moved in 1967.
But, okay, 1967. I know, I mean, I know for a fact it was here by that date because I have a pamphlet that was addressed to GISS and stamped. But that may be. This is a GISS staff roster from 1968 from an old GISS brochure that I spied among some junk being taken out of Jim's office, and that Zoe kindly allowed me to borrow with my urgent insistence. But here we see a realization of the original idea that the Institute maintained a very small permanent staff, but a relatively large number of postdocs that would come on staff for 1 or 2 or 3 years. Among them, Dr. Hansen in that time, 1966 to 67. It's impossible to summarize the work done here over the years. I thought at first I could do a reasonable job of that, but I just gave up and picked out a sample of some of the work that's been done here. From the very beginning, or at least the early 60s, there was an interest in Earth observations with the new Tyros weather satellite platform, and there were papers by Ichtiaque Rasool and Albert Arkin about the Earth albedo and the energy balance and the climatology. An important resource in the work done here was the mainframe computer, for a time state of the art. The first big computer, the Interchurch Center, was the IBM 7090, and I understand it was moved here at some point. They decided they needed their 19th floor back. And then at some point it was replaced, I guess in 1968, by the IBM 36095, one of only two built, or Gary tells me there were really three, and one was kept by IBM. One shipped here, one shipped to Space Flight Center in Greenbelt. This monster computer had 5 megabytes of core memory and an access time of 67 nanoseconds. And Gary tells me there were 3 computer engineers always on staff here, and that it took up almost all of the second floor. Later there was an Amdahl machine, and but that was eventually shipped down to Space Flight Center with Milt Halen's group. There was an interest early on in atmospheric dynamics. I was amused to see in this brochure mention of a seminar conducted by Robert Jastrow on the solutions to the equations governing the circulation of planetary atmospheres. I wish I could have been here to view those solutions. I can't read them off the blackboard. But at least there was an interest in that from early on. And for a time, GISS enjoyed the consultation and the frequent visits of Jule Charney. Jule Charney was, you might say, the father of geophysical fluid dynamics. He was Joe Pedlowski's thesis advisor. He advised Inez Fung, who was a staff member here for many years. And he apparently was on hand with Dr. Jastrow to recruit Ichtiaque Rasool to the Institute during a meeting in Helsinki. And Jim has said that Charney provided some high-level advice back in those years. You might, if you work in meteorology, you might be surprised to learn that the first meteorological data assimilation experiments were done here. Charney had the idea that maybe you could get a GCM simulation going and just directly insert the radiances or the temperatures corresponding to what would be the orbital ground track of an Earth-observing satellite, and see to what extent the model simulation came into line with the observations. And I gather that really didn't work very well, and that there are today much better methods for doing data assimilation. And now there's a major office for that, of course, down at Greenbelt. In fact, that group, again, was taken down there to do that kind of work under the leadership of Milt Halen. But
I might question your use of the word enjoy. For instance, I spent a summer here as a grad student in 1976, and the visitor's office that Charney, among other people, used was right across from my office on the 6th floor. I don't remember whether it was Gary's office or Barbara's office by the time, but and the people who were working in Milt Halen's group, every time he came down to visit, I guess he would have given them things to do from the last time that he had visited, and so they'd bring them their printouts from the model, walk into his office and show him things, and a lot of times he was not satisfied with, with what they had done, and he would let you know in no uncertain terms when you had not met his expectations.
Yeah, I heard that Dr. Jastrow would come in and chew out Jule Charney, and then Charney would turn around and chew out Milt Halen, and then I don't know who Milt Halen turned to. But it went.
You had a guy named Quick. You remember Larry? Do you remember Gary?
Yeah, he was part of
Quirk.
Yeah.
I think he was the one under Helen who would then be at the end of that chain.
Well, anyway, I think from today's perspective, we might say that the really the more important work of Charney in connection with the Institute was his use of the GISS model in parallel with the GFDL model to make a first rigorous assessment of climate sensitivity. And he wrote this famous National Academy report that's often quoted by Jim and others today, with the conclusion that CO2 doubling will result in a 3°C warming, but with a big error back then of plus or minus 1.5 degrees. Of course, Gary and others are doing a lot of good work now to kind of refine that sensitivity estimate. But that was a part of the work done here. Well, I wanted to come back to this book because it represents for me some of my own romantic engagement with the space age and planetary reconnaissance, although I've only written one paper myself on Venus with Tony's help. I think Venus is a very interesting problem, and as a kid, this book seized my imagination with its portrayal of 3 different extreme scenarios for the surface of Venus: a jungle of dinosaurs, a global ocean, and a global desert. And believe it or not, there are, you can find suggestions of those kinds among famous scientists and astronomers, from Arrhenius to Menzel to Adler. But of course, it was really none of the above. One person, again, to do significant work on that problem was Ichtiaque Rasool. His life reads like an adventure novel. It's just an incredible thing where he came from as a refugee from India, and being picked up here and there by someone who befriended him and set him on course to become a PhD candidate in Paris, and finally come to America. Not finally, he's back in Paris now, but he just has led an incredible life. But he was a co-investigator on one of the Mariner spacecraft to explore Venus, and he wrote a very interesting paper about the runaway greenhouse effect. This seems to me arguably one of the first Goldilocks studies. He attempted to calculate the evolutionary path of rising surface temperatures on Venus, Earth, and Mars, accounting for their different albedos and their different distances from the sun, and suggesting that that as water vapor accumulates in the atmosphere, of course, these atmospheres are warmed, but to an extent that's halted on the Earth and Mars because they hit the saturation point for water, and the water then condenses or freezes out. Whereas on Venus, the water's never saturated, and the temperature just runs away. I think, in fact, Andy Ingersoll was the first person to use the term runaway greenhouse effect, and he wrote his own paper about it. But I think, arguably, this is the first paper to discuss this in such a comprehensive and comparative way with those 3 planets. And this paper is still quoted in studies today of exoplanets and in context of the fake sun problem.
Mike?
Yes.
On the just as another historical note, that since you mentioned Rasool, on the day in 1988, June 1988, that Jim testified before Congress in the middle of the heat wave and became famous or infamous or whatever you want to call it for testifying that the greenhouse effect is already here. Actually, he and David Rind and I were down in Washington that day at NASA headquarters for a meeting with a bunch of other scientists that was led by Rasool, who was at headquarters at that time, and nobody there except David and I knew that Jim was about to go testify before Congress and say that the greenhouse effect is already here. And during that meeting, in fact, people made statements to the effect that well, no one believes that we've detected the greenhouse effect yet. Right. But Rasool was there to, among other things, proudly announce that he had secured $2 million, if I remember correctly, for studies of the greenhouse effect, and was all excited about it. Expected the attendees to be excited about it. And Jim looked at him after he said it and said, "I think you left a 0 off."
Yeah, Rasool after.
Rasool did not appreciate it.
Yeah, yeah. Yeah, Rasool went to headquarters when he left the Institute and did a lot of things there, but was partly involved in the Earth Science Office. Well, of course, he wasn't the only one to come here and begin to work on Venus. Jim Hansen had written his doctoral thesis in Iowa about one way of trying to address that problem. It turns out not to be what we know about Venus today, but he explored the idea that, well, see, Venus had, it's very reflective, and it's one reason people imagined it could have a habitable surface is that the infrared temperature is not so high there, but there were other indications from microwave, long-wave, centimeter observations that there's something deeper that's much hotter. And Jim attempted to model that with a dust insulation model, the idea being that aerosols may have trapped the heat from an internal source on the planet. And so in a way that was an anticipation of some of the physics of volcanic aerosols, I guess. But it's a place where he cut his teeth on this problem and developed an interest in making the observations with the tool of photopolarimetry, and successfully proposed just a few years later the Pioneer Venus Orbiter Cloud Photopolarimetry investigation, which was enormously successful. So here is the cover of Science, proudly publishing 30 different papers from the Pioneer Venus mission, including the GISS OCPP instrument, but reprising this fun idea that maybe Venus was a jungle. I think that's the last time it's been seen. This is the famous so-called Yellow Peril series of the images. This instrument was not just a polarimeter; it was a spin scan device that could build up an entire picture of the planet, and so it could also be used to study cloud morphology and in a way that could even be temporally tracked to produce wind maps. And GISS is a kind of nice public relations vehicle, printed up hundreds and hundreds of lithographs of these images. And I have my set, but I think they're probably all gone. So in thinking about this, I thought I would just try to compile a list of all the GISS staff affiliations with planetary flight teams, beginning with Rasool, involved with Mariner 5, and continuing with David Coffeen on Pioneer, Ichtiaque and Jim and David on Voyager. A couple of weeks ago, Ed Stone was here over at Columbia, and Ichtiaque and I got to review old times with him. I was a graduate student intern on Voyager at Goddard, but never a real team member. Again, PV was enormously successful. Some years later, we had here at the Institute an experiment on the Galileo mission, and I'll say a little something about that later. I was for a short time an add-on member to Mars Observer and Mars Climate Orbiter, and was attempting for a time to develop some objective analysis capability for thermal sounding measurements using a modified version of the GISS GCM. But both those missions failed just as they were about to go into orbit. One through a metric to English conversion error. They flew in too low in the atmosphere and burned up. And the other, no, I guess that one just blew up. But one of them had some kind of a conversion error, and it was misnavigated. And I kind of dropped it soon after that. But Tony and I have been involved in Cassini, Tony on the imaging team, and I've worked a little bit with the radar and Huygens Doppler wind experiment, and I've now more recently done some work with the Juno orbiter. I've received a lot of pictures just in the past couple of days that I greatly appreciate, and I've tried to put some of them into this presentation. This is a photo of some GISS staff members looking over Voyager images of Jupiter. I wanted to say something about the astrophysics at GISS. GISS has this famous claim to having been the source of important contributions to the astrophysical lexicon. The original GISS staff member Hong Yin Chu wrote a review of quasi-stellar radio sources that appeared in Physics Today, in which he coined the term quasars, and that stuck. There's this famous story about black holes, and John Wheeler, in his autobiography, remarks that he was invited to give a talk here by Vittorio, and it was a conference on pulsars, and he was suggesting that maybe the core of a pulsar has a fully gravitationally collapsed object that's inside its own Schwarzschild radius, and he said, well, I can't keep saying gravitationally completely collapsed object, I need something else. And somebody said, how about black hole? And that name stuck. Now, Vittorio, the Wheeler says in his autobiography that this happened in the midst of a colloquium, but Vittorio insists that it actually happened inside of his office. So I don't know. But meanwhile, I wish Vittorio were here to give his perspective of that. But a science writer, Marcia Bartusiak, has noted that in fact the term was used a few years earlier in a couple of conferences, one in Texas and one again in Cleveland, but organized by GISS staff members, and this term was flying around then. But Bartusiak concedes that the term only stuck after John Wheeler used that term here. So GISS does have a claim to that. Caleb Scarf mentions that also in his book, Gravity's Engines. Vittorio let me have this copy of a letter from Dirac announcing his travel plans to come to GISS and give a colloquium at Vittorio's invitation, and I understand that this room was so flooded that Carl had to go around and set up TV cameras for the audience overflow. But for a time, Vittorio worked with Dirac, playing around with the idea of variable G cosmologies. So now on this chart, I want to just explore a little bit the transition to climate modeling as I know about it. And I do not know, Jim as well as many of you, so I don't want to put too much claim on that, but I have always put up my ears whenever he had something to say about the decisions that he made. And I spent some time digging up archives, including this interview of Jim that you could find on the website maintained by the American Institute of Physics. And I've heard Jim say many times that he was strongly influenced by Don Hutton. At first at a conference in Washington where they were discussing the importance of modeling chlorofluorocarbons and ozone. And Don Hutton, a renowned planetary scientist and astronomer who hardly did anything on the Earth that I'm aware of, suggested that, well, this country really needs to have a better tool for studying these important issues. And he suggested to Jim that he really ought to develop a 3D model. And so Jim did that, building on the work that had already transpired here for many years with Rick Somerville and Gary Russell and others, going back to the old Arakawa model. And I'm sure many of you know a lot more about this than I do. But it was not long before the group here came out with this famous landmark paper on global warming, 1981, which makes some discussion of Venus in comparison. That's what Tony was talking about. But it was picked up. Jim Jim admits that he sent an advance copy of this to Walter Sullivan, the famous New York Times correspondent, and Sullivan put that, or the Times put that on the front page. So GISS was on the map and off and running with this new line of research at that point. I felt that I should at least address the awful fact that Robert Jastrow, after he left the Institute, postured himself as a skeptic on global warming. While he was here, he reportedly was very supportive of Jim in the climate modeling. But after Jastrow left, he helped found a conservative think tank and was also at the Mount Wilson Observatory. And he co-authored papers attempting to challenge global warming. And I just don't know how to explain that. I read in his New York Times obituary that his old friend Al Arkin would go and talk to him and argue with him, and at one point Jastrow said, "Yeah, you're probably right, but this is the way we have to put it." I don't know. Sometimes I think that the mental museum of every great and accomplished person has one misplaced exhibit in it. And you can think of many examples of that. But I like to remember that back in 1967, before anyone was thinking about global warming, Robert Jastrow put down a little footnote at the bottom of the page of red giants and white dwarfs saying that, in fact, the burning of coal and other fuels since the start of the Industrial Revolution may already have released enough CO2 to cause appreciable warming of the Earth's climate. So, should have stayed with that, I guess. But, well, there were lots of reorganizations at Goddard in the 1980s. When Dr. Jastrow stepped down in 1981, Jim was temporarily positioned as the acting director, and given his choice for the reassignment of the Institute at this vaunted place up at Code 130 off of the director's office, somewhere down under some other office, and he was told that he could go either with space science or with applications. That then was the term for Earth studies. And I remember Jim saying, well, he liked the space guys, but of course, given the emphasis on climate modeling, it made more sense, I guess, to position the Institute under the Earth office for the funding lines. But planetary science continued to be active here, and astronomy was active for some time. And in 1986, Space and Earth were rejoined in the newer 1987 GISS brochure. It says on the second page that GISS is a New York division of Goddard's Space and Earth Sciences Directorate. This is what the chart looked like at that time. This is Space and Earth Sciences. You can't even read the thing now, but GISS was one of 9 labs and divisions under Space and Earth. And we had lots of friends in these other divisions. Our own Marvin Geller was the head of the Laboratory for Atmospheres. Milt Halem from GISS was head of space data and computing. Hasso Neiman, who's done a lot of planetary probe work, was housed in Geller's laboratory. The Voyager Iris team, and now the Sears team was at the Laboratory for Extraterrestrial Physics. But I think, unfortunately, GISS was later, the Space and Earth was again split apart. Here we have a bean counter on the, somebody, Tony said, had a weird sense of humor down there to dare to put that on the cover, but in that issue of the Goddard phone book, you can read a new division of the organizational structure with Space and Earth split apart. If you want to read more about the sordid details of all of that, I recommend Emily Michaud's doctoral thesis, which you can download from the GISS website. Well, this is GISS in more recent times. I wanted to mention Pat Thaddeus, who was still here through the mid-1980s. He was a radio astronomer I might say almost a galactic cartographer with his mapping of the Milky Way. He actually had a telescope, a radio telescope on the roof of this building that was identical to another on the roof of Pupin Hall. And it was a 1.2 meter radio telescope operating at about 2.6 millimeters, selected for the observation of the carbon monoxide line. And as Pat says so poetically in an interview published in the New Yorker, at that frequency, the city is perfectly quiet. It's as far as we're concerned, he said, the New York environment is as quiet as it was when Henry Hudson came up the river. So he and his students actually mapped the galaxy from the roof of this building and over at Astronomy, Columbia. But he soon moved this down to Chile so he could do the southern hemisphere as well. And now, of course, those are gone. He moved to Harvard around 1986. This is the Galileo mission. I guess my chance to come to the Institute was because of my experience with Voyager as a graduate student, and we were looking forward to this new mission to Jupiter with another GISS instrument, a photopolarimeter radiometer, which unfortunately did not turn out as well as we hoped. This project was plagued with problems. Its launch was delayed again and again. And originally it was supposed to be launched on a Centaur liquid-fueled rocket deployed out in the bay of the space shuttle. When Challenger blew up, they said, well, we better not do that. And so they reconfigured it. And it had this deployable umbrella antenna, which didn't work when it had to deploy after its first Earth flyby for a delta V gravity assist. And so the data had to be played down through a low gain antenna painstakingly as read off a tape recorder, and the tape recorder had some problems, and then the GISS instrument had some problems with its filter wheel. It was slipping and sticking in a way that Larry could tell you about. But as a result, the data return was not what we hoped, but it was still a magnificent mission, and in particular, this orbiting bus carried a probe that was dropped into the atmosphere of Jupiter, which gave us our first and only in situ measurements of wind and temperature and composition. We'll never have another one of these in the lifetime of anyone here, I predict. It's so hard to make the thermal protection for this. The facility that manufactured it at Ames has been shut down. But there's another chance to Jupiter that I might mention later. I remember I was talking to Jim about my work on Jupiter at the Christmas party in 2011, and he reminded me that he once wrote a paper about Jupiter with Makiko. And so here are two GISS Jupiter scientists, two among many who've worked on this problem over the years, including Rasool and Joe Hogan and Roger Obsbaum and many others have worked on Jupiter. Barbara Carlson, Bill Rosso, Andy Lasis. So there has been a lot of work here on the modeling side of the problem. And so I tried to make sure to plot. I was assembling a single plot of all the data we have for the vertical distribution of ammonia and water in Jupiter's deep atmosphere. I made a point of adding this to Sato and Hansen to a chart that I hope will appear eventually in Space Science Reviews. This on behalf of a new mission to Jupiter now on its way called Juno, which carries a 6-channel microwave sounder that we hope will look all the way down to the bottom of the water cloud. I wanted to say something about space and the GISS library. How do we remember all this stuff? One way might be in books and libraries. I'm admittedly a very old-fashioned guy, and I like books and I like paper. But I think it's a shame that libraries are closing everywhere Goddard Space Flight Center closed its magnificent library a couple of years ago. The Johnson Space Center closed its library years before that. You know that story. I think that often browsing enables serendipitous discovery. One day I was at Goddard in their library and just stumbled onto something among some books I was looking at just for fun that suddenly gave me the light bulb to understand how to calculate something. And I would not have known how to search on that. Our library has magnificent gems of old books and atlases in its collection. If you want to have some fun, sometime go up and look at the big cabinets near the front of the library that house the atlases. You can pull out these sliding drawers, and there are huge portfolio-sized bound volumes of lunar maps and Antarctic ice charts, H-alpha emission from the Milky Way, spectroheliograms, just an incredible treasure of old books and maps there. There's always pressure to close down the library, and I think that I'm sure there'll be more in the years ahead, but the fact that we still have a library now, I think, is a tribute to, again, to Dr. Hansen, who insisted that we hold on to some funding from headquarters to maintain our collection. I wanted to feature Richard Stothers, who died in the summer of 2011. He was, again, one of the early staff members going back to the 60s. I so much wish that I had systematically interviewed Dick about the history of the Institute, but sometimes I'd see him here late at night. He would come in about 4 o'clock in the afternoon and then go have dinner at Tom's, and then he'd stay here till about 2 in the morning. But he was an incredible scholar, again, a polymath working on stellar evolution and dynamics and cosmology and historical supernova. He could read Greek and Latin, and he would use that skill to go into historical archives to surmise what could be learned from ancient records of clouds and volcano eruptions. He once made a comparative analysis of various pulsar dating methods that corroborated the very interesting idea by Michanowski that the rise of civilization was stimulated by the Vela supernova explosion. There's at least some evidence that in the cuneiform writing that all of a sudden people started writing and working arithmetic after some event in the sky. And Dick at least provided some plausibility to that idea in the 1980 paper. As you no doubt know, there's a plaque in his memory up in the Stothers reading area of the library. Now I have a few even more whacked out slides to show you. These really just kind of personal nostalgia connections that I have with this place in those years. I really think there is a kind of mystique to this place. When I first came to GISS as a visiting graduate student, I thought I had the address in my head, 2880 Broadway. I couldn't find it anywhere. This was before the internet, before Google Maps. Couldn't find it. I went into Tom's Restaurant. I said, "Can you give me a phone book?" "Sure." I looked up Goddard Institute, 2880 Broadway. They said, "That's this address." And we scratched our heads, and finally I went around the corner and found the entrance. But I told Bill about this, and he was my NRC advisor. He was the person here who first made it possible for me to come to the Institute. He said, yes, we could maybe arrange to walk through the kitchen to enter the building in the same way as the secret agents on an old television show called The Man from U.N.C.L.E. in New York City. On the street in the 40s, there's an ordinary tailor shop. Or is it ordinary? They walk through this brownstone, and the tailor buzzes them through, and then they're inside this spy headquarters. So that's kind of the feeling I've always had about this place. I remember I was talking once with Pascal Lee, who's a kind of very far out planetary scientist at the SETI Institute, and he said, NASA in New York, he'd never heard of this place. He said, that sounds like a dream. And as recently as a couple of months ago, one of my astronomy colleagues over in Columbia was emailing me about a visitor, and he said, I'd be really curious about this top secret operation you have going above Tom's. Some of you probably know Steve Scipio. He was down on the street this morning. You know, I saw him packing up, maybe because it looks like rain, but he's our bookseller, and he was written up in this New York Times article some years ago in connection with the Goddard Institute, and in particular with Jeff Berry, who's one of his best clients, and who has a reputation of buying one book a day from Steve. Steve says that he studied creative writing over at Columbia and wrote a master's thesis on science fiction and about Theodore Sturgeon. For me personally, it's a wonderful juxtaposition of buildings and opportunities here that were just down the block from the Cathedral of St. John the Divine. I think Jim likes that place. He's talked there at least once, and he likes this view of the street and the block. And when we held the conference on the Jupiter atmosphere, Jim, as a part of his opening remarks, recommended a tour of the cathedral to our participants. And one of the participants, Conway Leovi, the meteorologist, went over there and he saw this window of the planets, and in particular saw this slanty feature on the depiction of Jupiter, and then came back that afternoon and in his talk interpreted that as a stratospheric breaking wave, or at least an analog to the stratospheric breaking wave for the surf zone of the Earth's stratosphere. Well, I don't know. I don't know if today even the term space age seems like kind of a quaint and out-of-date thing. This is maybe today, if anything, the information age or the digital age. About a year ago, I happened to be walking north on Broadway and noticed the space shuttle flying over Columbia, and here is a shot of that taken by someone in the astronomy department at Columbia flying past Riverside Church. A year earlier, The Economist announced that we're now at the end of the space age. Inner space is useful, outer space is history. Well, I don't know. Certainly there's been a decline in the extravagant expansion of spaceflight opportunities that we had in the 60s, in the 70s. I was talking to Dick Stothers about this one night in the library, and he said, well, you know, it was 100 years after the first exploration of America that we had the opening expansion of the American continent. And so maybe we're right on time. At any rate, NASA has a few good moves left, I think, even in space science. Juno is on the way to Jupiter to arrive into orbit there in the summer of 2016, and New Horizons will do a fast Pluto flyby in 2015. But I thought at first I would end with this slide. I've always loved this this banner that Rob put together for our webpage, and many of us have used this as the kind of flag for the charts that we present. I got Rob to make me the largest possible view of this that he could. But I've always thought this is a wonderful depiction of all the things that we do and have done, from star clouds to planets to water clouds to the whole Earth, all in New York City. But then I thought, well, really, it's not just the research topics, or the computational techniques. What makes this place work are the people here. And so now I'm just going to close this talk with the quick run-by of a few photos that Makoto and Makiko kindly shared with me.
Wait, as you go through, I recognize many of the faces behind.
This is Barbara Carlson, Joe Ferrier, Andy, Jim, Larry, Gary. I don't know who this is.
Ravi Bhattacharya.
Thank you. Bill Rosso, Jim, Tony, Sergei Lebedev, who did the kind of statistical work for Jim that Makiko does now. He was a very talented applied physicist, a wonderful guy who died tragically at the age of about 60, I guess, some years ago. This is Sanjay Lamay. I don't know if that's his wife. Sanjay was working with Bill on the Pioneer Venus data, but then moved to Wisconsin, I guess. I guess still somewhat active in planetary science. So thank you for your attention. I may not be the best person to have done this talk, but maybe now, if you have any comments or questions, I can welcome them.
Yeah, I have a question. The rocket from the first Soviet satellite, where did it actually land?
Well, Jastrow claimed that the most probable impact site was Outer Mongolia. And
Was it ever discovered?
He suggested you ought to go look for it. But to my knowledge, it either was not found or they wouldn't admit it. But of course, that's pretty barren.
So it's never
really
found in the
doesn't-
United States.
Yeah.
Not what they said.
Questions welcome. Come on. When are you going to get a chance to ask this guy?
Or corrections. I again humbly acknowledge that a lot of you know a lot more about some of the things that I've said than I do, and I'm sure many of you could provide useful corrections to this. I guess I hope to make available some PDF version of this talk or some edited version of it for you to download. But I would welcome any contributions you'd have to it, and then maybe someone else could pick up this history from a different point of view. Elaine.
I don't have a serious contribution, but I did collect when sort of mass mailings were still going on and there was a limit to how many letters you could put into an address. I have a large collection of extraordinarily oddly addressed mail, like to Mr. Inst Stud and things like that.
Yes. Yes, I've had a few of those myself.
Oh.
Yeah.
You could have my folder.
But I'd like to see them. Yeah.
Elaine, how come you're not in any of these old pictures?
They only took pictures of men. I am in though Jule Charney's and Sergei Lebedev's talk, which makes you want to.
I apologize for all the people I've left out. I decided it was impossible to be comprehensive. Well, I don't know. I mean, my experience here it owes a lot to everyone I've never met.
Should put this together as kind of a yearly intro, orientation to new people.
Yeah, I wish there could be some kind of a history stack in the library. There is a section of bound volumes of printed reprints year by year, and some special reports that were written at that time. But I found nothing like an organized history. Nancy.
I think we should find a UTO person actually assemble these into just a nice documentary kind of, with, get some actors when they do the narration. It would just be a nice thing to have. That you already assemble all these images.
Hey, Goddard showed me a reel of like video footage from like I think the late '60s.
Of what, just people?
Yeah, it's like one of those, where the kind of announcers voice over of how exciting space age.
Yeah, I understand that Robert Jastrow did a series of television programs for CBS, and I would love to view those, but I have no access to them. I don't know. When was GISS changed from 640 to 611?
When the space science and earth science directorates were recombined some years ago, then the earth science directorate used codes starting with 9, 930, 940, etc. And space science used 600, starting with 6. When they combined the two directorates, then they reorganized the boxes, and that's when we ended up being 611, which is part of the Earth Science Division, which is 610. Earlier, we had been like a standalone division.
Okay, thanks again, Mike.